Here we go with our last four from this test review. Number 25 is y equals 2 secant of theta over 3. Going to be very much like number 24, which was on the previous video. Remember, what we're going to do is we're going to start by graphing y equals 2 cosine of theta over 3, because that's the reciprocal. So for cosine, our phase shift is 0. Period is 2 pi over 1/3, which ends up being 6 pi. Amplitude is 2, and there's no vertical shift. I already have my y-axis drawn in here, but I'm actually going to change this up again because for secant and cosecant, since you have those u's and n's, you kind of want more of a y-axis there. All right. We'll start by graphing y equals 2 cosine of theta over 3 in blue. So we have our starting point is 0. Pick an ending point out here. Actually, I'm going to go a little bit further because this is 6 pi. This is pretty far out there. Just realize normally this would be one full period would fit in 2 pi and then another one and then 6 pi. So this is very much spread out. So half of 6 pi is 3 pi. Half of that is 1.5. So these calculations here for the quarters are easier when you're dealing with easier numbers. Amplitude's 2, so go up to 2, down to -2. I'm going to put some guidelines in there to help me. This is cosine, so cosine starts up at 2, goes down to 0, down to -2, back up to 0, back up to 2. I'll put one more spot on here. I'll come backwards a little bit, put a couple points there, and we will graph this as a dashed line because this isn't part of our answer. This is just used to help us get our answer. And so now we want to graph the actual equation, which we know wherever cosine crosses the midline, which in this case is the x-axis, there will be a vertical asymptote. So in what I have here, we can graph 4 vertical asymptotes. And then we can graph our shapes in here. Remember, they touch the the valleys and peaks of the cosine graph. So they touch just at that point. And so there is a sketch of that graph for number 25. All right, 26. This looks like it could be interesting here. We have a phase shift of left pi over 2. We have a period of our normal period, which is pi. For tangent, normal period's pi divided by 1/3, which is 3 pi. Amplitude and vertical shift are not applicable there. So let's go ahead and draw in our x-axis. We're not going to put the y-axis in quite yet. Our starting point is at -pi over 2. The end of our first period, so the period's 3 pi, so a little bigger, so I'll put it down here. The end of our first period is 3 pi. Sorry, is not 3 pi. The period is 3 pi, so we have to take -pi over 2 plus 3 pi, which is 2.5 pi, or 5 pi over 2. And so our endpoint is here at 5 pi over 2. This is tangent, so those are both going to be zeros, and then halfway between there is going to be a vertical asymptote. So let's find the middle of that. To find the middle, you take those 2 points, add them together, and divide by 2. Or you can think through it and figure this out, probably a little bit easier, but we're going to do it this way for now. So this is 4 pi over 2 over 2. We know dividing is the same as multiplying by the reciprocal. So we have 4 pi over 2 times 1/2, which is 4 pi over 4, which is just pi. So this middle point right here is pi, which makes sense because our period is 3. If we split 3 in half, we get 1.5 pi. Add 1.5 pi gives you pi. Add another 1.5 pi gives you 2.5 or 5/2. What we'll do is we'll put another mark here and put this vertical asymptote. We could go back another 1.5, which would put us at -2 pi. And then we could do one more vertical asymptote. And then we can graph this. So this is tangent. So it goes up from left to right. Make sure you use your vertical asymptote. Goes through the 0 and then gets closer and closer to the vertical asymptote. All right, 2 more left. Number 27 is just y equals cotangent theta. So what we're going to do is we're just going to graph y equals tangent theta, which is earlier on this paper. There's no phase shift. The period is just normal pi for a tangent. There's no amplitude. There's no vertical shift. So we can, since there's no phase shift, we can put our y-axis right in there. Here's 0, pi, halfway between there. So this is tangent. So these are both going to be zeros. Halfway between is going to be a vertical asymptote. So this is pi over 2. At negative pi over 2, there will be a vertical asymptote. And then at negative pi will be a 0. We could go another one if we wanted to, which might be a good idea just for specifically when we're doing cotangent. Now, I'm going to try to make this a really different color so it doesn't throw us off. So let's go with yellow. So when we do reciprocals with trig, when we have a vertical asymptote, the reciprocal will be 0. And when we had a 0, we'll have a vertical asymptote. So here we would have a 0, vertical asymptote, 0, vertical asymptote, and a 0. Oh, I'm sorry, I didn't even graph tangent in there. Let me go back to my blue ones. Here's tangent, which you don't technically need it because we probably could have thought through it, but here's tangent. There's that middle section. All right, so that was tangent. That's not what we're trying to graph. We're trying to graph cotangent. So just remember, cotangent comes, when you make one of these branches, it comes down left to right. So here's a 0 right here. I'm trying to make it big so you can see which one I'm pointing at. So this is going to come down. So we have this vertical asymptote, and we're going to come down, go through that 0, and then get closer to this vertical asymptote, and we can draw a few of those. So down, go through the 0. So there's a few branches there. Over here on the far left, we can put part of one as well. All right, so the yellow part is y equals cotangent theta. All right, the last one. Y equals tangent of 2 times theta plus pi over 4. I don't even have any of my things written here. So phase shift, period, amplitude, vertical shift, phase shift is left pi over 2, sorry, pi over 4, period, the normal period of tangent is pi, but it is divided by the number that's multiplied out here by theta, so over 2. Amplitude, tangent doesn't really have amplitude, but it's not any steeper, so I'm just going to put them slash here. There's no vertical shift. So we're going to draw our x-axis. I'm not going to draw the y-axis yet because we have a phase shift. Our starting point is at negative pi over 4. Period is pi over 2. So we want to take our negative pi over 4. Pi over 2 is pretty short, so let me shorten this up a little bit. And we can put it kind of wherever we want, but there's going to be our end. We're going to take negative pi over 4 plus pi over 2. Well, that's a negative quarter plus a half, which is a quarter. You can get a common denominator and verify that if you need to, but our ending point is at a quarter. Well, that works out very nice, actually. So tangent goes through 0 at the start, goes through 0 at the finish. There's a vertical asymptote right in the middle. And what is that value? Well, that should be really easy to figure out since we had a negative pi over 4 and a pi over 4. This is 0. And then this is going to be pi over 2. The reason I know that is here's a 0. If I add the period, which is pi over 2, we would be at pi over 2. So that's going to be another vertical asymptote. And we can stick another 0 on there. And then we can graph tangent. All right. And there is our review.